Hello, everyone, and welcome to another session of Health and You. My name is Dr. Amit Abraham, and I am an assistant professor here at Weill Cornell Medicine in Qatar. But a little bit about the Health and You Community Wellness series before we begin. The overall aim of the series is to try and create community awareness about health and disease, and we're trying to enhance self-care, reduce suffering, improve quality of life, and increase healthy longevity. Please note that this activity is for the general public, so this is not a CME CPD activity. A few housekeeping rules before we begin. Your cameras and microphones have been switched off. However, if you have any questions or comments, please feel free to use the Q&A feature or the chat, and we can relay these questions to our speaker. Any questions will be addressed at the end of the session. And just to reiterate, this is not a CME CPD activity, so there will not be any certificates of attendance. So it gives me great pleasure to introduce our speaker for today, Dr. Sadeer Al-Kindi, and he will be talking about how the environment shapes our health. A brief bio as we start. So Sadeer Al-Kindi is a preventive cardiologist, physician scientist, and leader in environmental and precision cardiovascular health at Houston Methodist DeBakey Heart and Vascular Center. He serves as the Gerald B. Katz Translational Investigator, Medical Director for Environmental Health and Prevention, and co-director of the Center for Computational and Precision Health. Dr. Sadeer is also adjunct faculty in electrical and computer engineering at Rice University, and actively collaborates across engineering, data science, and clinical medicine. His research focuses on integrating advanced cardiovascular imaging, artificial intelligence, and large-scale environmental and neighborhood data to understand how external exposures shape cardiometabolic disease, aging, and resilience. He leads multiple projects examining the role of air pollution, climate, and built environments in cardiovascular and metabolic outcomes. Dr. Sadeer has authored more than 450 peer-reviewed publications and is deeply committed to mentorship, workforce development, and translating data-driven insights into actionable prevention strategies. He's both certified in internal medicine and cardiology and is a frequent invited speaker on the nexus of climate, environment, and cardiovascular health. Dr. Sadeer, the floor is yours.
Thank you so much for the kind invitation and the introduction. And let me start by sharing my screen. And I want to preface by saying that I graduated from Weill Cornell. It's been more than a decade now, but I'm glad to be able to continue to contribute to the mission of Weill Cornell Medicine in Qatar. So I know these are difficult times now, and the environment may not be on everyone's radar, but thank you all for attending. You're able to see my screen, correct, Amit?
Yes, we can
Okay,
see us.
fantastic. Very good. All right, so today we'll spend the next maybe 45 minutes or so discussing the impact of the environment on health. And this is not an easy topic. It's very complex, and it requires probably, hours and hours of discussion, but I'll try to summarize it and just to give you a snapshot of what this kind of relationship is, which has been under-recognized for a while, and now it's receiving a little bit more attention. So let's start by kind of just examining that there is a very significant heterogeneity in the lifespan across the globe. This is, and I don't know in Qatar whether Netflix will have this as part of the portfolio for Qatar, but in the US at least, there is a really nice show. It's almost like a documentary that talks about blue zones. And blue zones are these areas in the world where people live consistently, been living more than 100. And you can see these are not in one area, meaning that the genetics are not responsible for this. This is not just one group of people. And they are actually in different groups in different countries where people start to dig a little deeper into this and why people are living up to 100 and more than 100 consistently. And it turns out that we cannot really explain it very well. We cannot explain it by genetics. Even the behaviors, we can't explain it 100% by the behaviors. So there's something outside, something bigger than us. And I believe that the environment is playing a big role into this. Many of these are actually coastal regions, which may have a cleaner air, different views and different immersion in nature that allows you to potentially live longer. Um, it's actually not something that we talk about a lot, but if you think about the most important risk factors for disease, for premature mortality, of course, high blood pressure comes out to be, this is globally. Blood pressure comes out to be the top, tobacco smoking, obviously, and dietary risk. But air pollution is actually the fourth most important factor for global mortality. And you can see this exceeds diabetes, obesity, cholesterol problems, kidney problems, and so on and so forth. Um, Also, it turns out that just air pollution by itself exceeds mortality from tuberculosis, from malaria, from HIV combined in the world. So you can see that the vast, the amount of impact that environmental pollution can impact. And this is just one part of environment pollution. Today we'll be talking about other parts as well. We are also realizing that our health is intertwined with our environment. So you can see heart disease, kidney disease, obesity. In the cardiovascular space, we're starting to realize that all of these are connected. Diabetes is connected to heart disease, obesity is connected to kidney disease, and so on and so forth. But more importantly, we're starting to put this as piece of the big puzzle where the health is also interconnected with the environment. So our transportation patterns, our housing structures, our healthcare access, food environment, our even energy use and water supply, all of these can impact health. And also, health by itself will also impact some of these concepts. You can imagine when people are not healthy, they have a high risk of diabetes, heart attacks, strokes, things like that. They would require more transportation, whether it's ambulance transportation or their personal use of cars. They will require more water supply, energy, and by itself can create this vicious cycle of health worsening, which worsens the environment, and so on and so forth. Although I'm a cardiologist, but we need to kind of also address the fact that our climate also impacts the other conditions, including cancer. So this is just a schema showing how climate change and cancer risk are intertwined. And one potential mechanisms is these wildfires, and UV radiation can increase risk of lung cancer and skin cancer. Floods and water contamination can increase specific vectors, kind of mosquitoes and things like that, that can also worsen health in patients with cancer. There is also some other vector expansion that can lead to colonic impacts and colon cancer and so on and so forth. So there's a lot of different cancers that are also connected with environmental pollution. And I will show you some data in the next few slides on this more specifically. So this is an interesting study that just came out literally a week ago that looked at all the published literature and showing you different types of exposures, different types of pollutants, let's say, particulate matter, nitric oxide, all of these are kind of human-made pollutants for the most part, but even included things like environmental pressure and environmental quality and UV light and green space. And what this is, did a comprehensive analysis of all published studies, peer-reviewed analyses, and showed that lung cancer here is linked, anything in red means positively associated with things. For example, if there's high air pollution, then there is more lung cancer. So you can see lung cancer is the most widely studied with respect to environmental pollutants. And for the most part, across across the spectrum of pollutants, everything is red. So suggesting that lung cancer is shaped strongly by environmental pollution. But there are other cancers that we don't necessarily think of as much, including breast cancer, we don't think breast cancer, in the traditional sense, we don't think of breast cancer as an environmental condition. It's a lot of it is genetic and behavioral. But it turns out that there's a lot of studies, at least 5 or 6 studies, that linked environmental pollutants with the risk of breast cancer. And there's a lot of different other smaller amount of cancers or multiple cancers. So even cancer, which we don't necessarily think about as a related to environment, it's actually showing up to be a significant contributor. So when we start to think about health, the health as an individual, we live within an ecosystem, what we call the exposome, or what we're exposed to, things that we're exposed to. And this concept really pulls into play various things that are related to the individual, but also around the individual, the communities. So we have the physical chemical environment, which includes things like, temperature, humidity, UV light, air pollutants, flood, soil, and things like that. We have also social determinants of health and the networking and the connectivity between individuals. We have a lifestyle, which is the internal kind of behavioral environment, and also this ecosystem around us, population density, the walkability, green bloom space, and so on and so forth. So all of these are intertwined to actually shape our health. But even beyond human health, we're realizing that there's this concept of One Health, where human health is also intertwined with the environment, which I showed you, but it's also intertwined with animal health. And you can imagine, I mean, coronavirus pandemic is a prime example of this, but there is other types of, if you remember the other coronavirus, which is the Middle East coronavirus, which was discovered in camels. There is other types of mad cow disease and other things. So not only that human health and our environment are intertwined and they're connected with each other, but animal health is also part of this planetary health or One Health concept that we like to address. All right. So whenever I give talks like this, is people tell me, okay, there are associations, but do we really know that whether, people who change their environment, do they change their health as well? Does the health change with respect to changing environment? And in the United States, we have a hospital system. It's a federal or government hospital system called the Veteran Health Administration. Basically, they track the patients because they receive benefits from this hospital. So they track patients over the decades. So we have data from them back to the 1990 until now. So there's 4 decades of data. And what this group has shown is that if you move from an environment, from a neighborhood, they tracked people who moved from one neighborhood to another. If you moved from an environment that has higher risk of obesity, then your obesity goes up. If you go to an area that has lower risk of obesity, your obesity risk goes down. The same thing applies for blood pressure, same thing applies for diabetes. So you basically adapt to your new environment by mimicking or kind of mirroring the environment around you. And that is not because you're mirroring with people. I think that's what's happening is that the environment that you're moving into could be an adverse environment that promotes diabetes risk or high blood pressure risk, and it could be a healthy environment where it promotes diabetes control, healthy control of blood pressure. We kind of started to talk about air pollution, but realized that there is a lot of different things that are happening more frequently, which is part of this planetary climate change, which really can be man-made, like oil spills and sometimes pollution and smog, but also tsunamis, which are part of this global change that is happening, and we're seeing more and more of this around the world. So I will spend for the next 5 to 6 minutes, maybe I'll spend some time talking about air pollution. And the reason why air pollution is so important, it's probably the most studied, the most impactful, and the most understood pollutant, environmental factor that affects our health. So this is a picture that I took. Actually, no, I took from the internet, but I have a similar picture from my camera. But this is when I was living in Iraq. I remember this day vividly because this happened after the war. So about few days after the war, there was a lot of smog that happened because of two reasons. We had a sandstorm that really made you can see everything is in orange and because of that sandstorm. On top of that, the Iraqi army at the time started to burn some oil around the capital, Baghdad. So what it led to is that this combination of smoke that is combined with dust that led to really, the very low visibility. But more importantly, we started to see within a day, we started to see so many hospitalizations because of asthma, because of respiratory issues, because of things that are leading to, especially in people who have asthma, who have COPD and bronchitis and things like that. But more importantly, we started to realize that after a week or so, you started to also see increases in heart attacks, strokes, and things like that. So these are less visible impacts. The more visible impact is usually respiratory. The less visible, which is arguably more impactful, is cardiovascular disease that happens because of air pollutants. And in fact, this is not a new thing. In 1952, in London, there was a significant amount of smog that happened. People were walking, there was a lot of storytelling that saying that when I walk on the pavement, on the sidewalk, I can't even see the street from where I'm walking. So basically, the visibility became so low. And this happened because there is a lot of human activity, pollution that is happening because of oil burning and furnace and all these things. But on top of that, there were significant weather conditions that made it that this pollution was really stuck in the air around London. And you have a lot of kind of clouds that kept this air pollutants and pollution and chemicals kept them in the air for a long time, and they started to kind of interact with the air, with the water in the air, with the humidity to cause this smog, which is really impactful from a health perspective. And after you can start to see, this is a very old study that showed that within days you started to see, this is day zero of this is basically where the smoke started to happen. And then within maybe a day or two, you start to see a significant increase in the number of deaths, right? So this is not a new story. We've known about this since the 50s at the very minimum. But I would say even going back 4,000 years ago. This is what's called Eber's Papyrus, which is the longest surviving medical document from ancient Egypt, from the time of pharaohs. And it's basically, I think it's about maybe 20, 30 meters wide. And it's still preserved. You can still see it in museums. And in this document, they talk about bad wind or foul wind causing health issues. Now, they didn't realize they didn't have the sophistication to understand what is going on and why, is this an environment thing? What is going on? But they realized even back then, this is more than 4,000 years ago, that about 4,000 years ago, that there is an impact of the environment on our health. And in fact, the father of modern medicine, Hippocrates, this is in the 500, approximately 500 years ago, mentioned he has a book on air, water, and the situation, and then medical diseases. And he says, it was in Greek, but kind of the translation says, whoever wishes to investigate medicine properly should proceed thus in the first place to consider the seasons of the year, then the winds, and also the waters and the situation of the ground, right? So they realized that environment has a significant impact on our health even a long time ago. And this is an interesting thing that I found is that although we think that pollution is a modern thing, is a modern kind of air pollution is a modern thing that happens, this is a thesis by a graduate student in England, in Oxford, I believe, where they started to look at mummies. They have a mummy from back in, the pharaoh's day, And then they started to look at their lungs, and you can see that these are soot particles. These are kind of air pollutant particles that approximately to 25 micrometer in size that they found in lungs. So at that time, there was air pollution that happened probably from kind of burning fire and things like that. And we still see evidence of it to this day in these mummies. And in fact, there is interesting studies these days that showed that you can actually see this in utero, meaning that in the placenta and the interaction or the intersection between the mom and the baby, if you take the placenta and that is full of blood vessels that feed the baby in the womb, you can see particles of air pollutants, especially in people who live closer to roads. So you start to see that there is evidence now that this is not impacting our health as older individuals, but also even from the beginning of life, right? So this has significant implications. And our conceptual framework right now, at least with respect to cardiovascular disease, we think that there is a chronic exposure that happens. And, for example, you get exposed to air pollutants, these particles over time. And then from this, you get a fluctuations of on top of it. So you have a chronic exposure, and then you have what we call acute exposure. And this chronic exposure leads to this plaque buildup or accentuates, promotes plaque buildup or this cholesterol buildup in the arteries of the heart, the lungs, and the legs and the brain. And you can have these spikes, which are air pollution spikes, that can destabilize these plaques. So these plaques are building up, they cause blockages, and then all of a sudden you get a spike of air pollution that happens that can destabilize this plaque and leads it to cause a blood clot, which is what we call a heart attack. So we talk about air pollutants, but what are air pollutants? The way I think about them, there are two types of air pollutants, two major types. There are ones that are solid, and there are ones that are gaseous. So gas, we think about ozone, nitric dioxide, sulfur. These are all chemicals that are existing in the air. Most of them are man-made. So nitric dioxide is a diesel related and kind of a chemical related to combustion of engines. There is carbon monoxide, as you know, volatile organic compounds. A lot of them come from perfumes and chemical industry, but a lot of them also come from oil and gas industry as well. And then the solid part, which is the most studied part, I would say, in air pollution, is we characterize it by these particulate matters. These are very tiny particles that are so tiny that they're suspended in the air. And we count them by their size. So we say coarse, so up to about 10 micrometer in size. We say fine, anything less than 2.5. And there's also ultra fine, which are less than 0.1 micrometer. These are tiny, tiny. And the concept that we have is that the smaller the particle, the more impactful on harmful from a health perspective, because you can breathe them and then they can go deep into the lungs and they can go into the organs and they deposit themselves in the organ. And just to give you a perspective, these particles that we talk about are approximately the size of a red blood cell. So 2.5 microns is approximately the size of a red blood cell, and 2.5 and smaller. So this aspect here is the most studied, the most impactful. And there is not the entire world is not exposed equally. You can see that this is a heat map of the world, this back in 2019, but very similar maps are generated today. And you can see that we have hot pockets or hot spots in the world where there is a very, very high levels of air pollution. And just to give you a context, the World Health Organization, the WHO, suggests that people should not be exposed to more than 5. So, Australians are living in a very healthy environment. Even in the United States, I would say relatively healthy environments. But when we go to Middle East, South Asia, Sub-Saharan Africa, or kind of North Africa, I would say, there is levels here that are 10 times, 20 times, 30 times higher than the healthy or the promoted levels, right? So that's where we start to see significant amount and burden of disease that is attributable to to kind of air pollutions and so on and so forth. And the relationship, when we study these relationships, whether it's air pollution with heart disease, air pollution with diabetes, for example, you can see that the relationship is curvilinear. So as you increase your air pollution exposure, you see a significant increase in cardiovascular disease. So just to give you a perspective, Qatar, I think, lives around 50 to 60 in the recent estimates, but maybe a little bit around 30 to 40. And that suggests that if you live in areas where 30 to 40 compared with zero, which is the ideal situation, the risk of having a heart condition is approximately twice. That's what we're seeing. This is what the data tells us, is you're doubling your risk by living in an unhealthy environment in some aspects. Now, with some caveats, there's some chemical composition that happens. We don't understand, for example, in Qatar, there's a lot of dust, we think, which may not be as impactful compared with other chemicals. But just to give you a perspective that in India and Bangladesh and South Asia, the levels are exceeding sometimes 100. And that basically puts you, just by breathing that air without protecting yourself, you're getting a risk of approximately 2.5 times. And the same thing, we see it for diabetes. And a lot of these curves have been generated from multiple and multiple studies. And I'm not going to go through this in details, but this has been worked up in terms of mechanisms. These are not just associations that we kind of found in studies, but really there are some deep science that have investigated all of these different mechanisms whereby air pollution goes into the lungs and the lungs kind of signal to the other organs, and even at the cellular level. All of this has been studied through multiple studies in humans and mice and kind of other animal models and cells. So there's very significant amount of science that has been built around this concept that air pollution, now we think of it as not a risk factor only, but it's a causal risk factor, which is a really high level of relationships that we study in medicine. The interesting thing is that there is for the most part, things are getting better. There are this is a change in air pollution trends over the past 2, 3 decades. And you can see that red means that there's things that are increasing, green things means that things are decreasing. And you can see for the most part, things have been either stable or decreasing in the Gulf region. Now, on the west side of Saudi, things have been worsening. And part of this, again, I want to caveat this by saying that there is a significant uncertainty around the chemical composition of air pollutants, and dust, for example, may not be as harmful as other types of chemicals. And dust is, especially tiny particles in the dust, are captured as part of the quantification. But still, we still see there are some areas where the air pollution is worsening in the west side of the Middle East. And then when we start to think about the Middle Eastern North Africa region, we see that the number of deaths that are estimated to be related to air pollution, just this PM 2.5 particles, has been increasing. And this is a combination not only because air pollution is increasing or decreasing, but the aging population. As population ages, people become more susceptible to disease, right? And you can actually see that household air pollution has been dropping, decreasing, but you can see that the deaths, only cardiovascular deaths, are increasing because of increasing population size and increasing population age as a whole. And we estimated approximately 350,000 cardiovascular deaths in the Middle East and North Africa region that were attributed to particulate matter, which is air pollution. Now, I talked a lot about cardiovascular disease, which is arguably the most studied linkage with air pollution, but I want to remind you that there is now multiple studies that have shown that air pollution is actually also impactful on the brain. It kind of makes sense to a certain degree where there is blood vessels in the heart, there's blood vessels in the brain, and the same mechanisms hits in both organs. But there is also some mechanisms to suggest that their Alzheimer's disease or the specific type of dementia can also increase. And we're kind of studying this and understanding how does this work, whether it's a neurotoxicity, toxicity of these particles to the neurons in the brain and the nerve cells, or is it more of an impact on cardiovascular kind of vascular structure or vascular health that leads to what we call vascular dementia. So I'm going to switch gears a little bit. We talked about air pollution, but I want to kind of switch gears. And in the next few minutes, I'm going to tell you about different types of pollutants. One thing that we're exposed to, a lot of us are exposed to, almost everybody is exposed to, but we don't necessarily kind of conceptualize it as a harmful from a health perspective, is noise, specifically transportation noise, but other human activity noise, right? Whether it's occupational, whether it's transportation, whether it's related to where you live, there is a lot of noise around us. And if you ask moms who have young children, the child cry is actually a very impactful noise or disruptor to the neurons and the stress levels, right? So you can think about noise also as a disruptor. And there is a lot of different manifestations of noise stress. Uh, this is a list of what has been shown in different studies, whether it's noise stress has been linked with delayed cognition in children. It can lead to psychologic triggers in patients with post-traumatic stress disorder. It can lower the noise threshold that results in sleep disturbances, increased heart rates as a result, and changes even in the immune system. And as a result, you kind of see that there is an impact on various organs. It can impact anxiety levels, annoyance, and mood shifts, cortisol production, which is a stress marker, high blood pressure, heart attacks, and adrenaline levels. So there's a lot of different impacts of noise, and that's something that we don't necessarily think about all the time, but it's a very, very impactful thing. And noise levels are captured by this system called decibel. And just to give you a perspective that anything above 65, between 65 and 70 is considered to be unhealthy, and above that is unhealthy. So a lot of things that we are exposed to, whether it's telephone ringing continuously, passenger car, truck, and obviously occupationally, jackhammer and rock band and things like that are very, very unhealthy levels of noise. And anything below that is a continuous risk, but generally it's safe. So the WHO, the World Health Organization, and Europe noise thresholds consider 55 to be abnormal, and there is different kind of studies that have shown that indirect noise approach 72. So about 60 to 6 to 70 is what we consider to be abnormal. And as I mentioned, it leads to hearing loss, it leads to auditory problems, but more importantly, it leads to this indirect non-auditory health effects, which are stress and inflammation, change in life habits. It can actually reduce exercise. It can increase unhealthy diet changes and things like that, which result in manifestation of disease. And this is what we call the dose response. So you're exposed to noise here at about 55 decibels or 60 decibels, you start seeing increase in the risk for heart disease and increase in the risk for stroke about that level. And we have analyzed some trials. There are some high quality, what we call randomized trials, because there are associations, but there's also causations. And what we see is in patients who we give them noise simulators at night at their bedroom. So when they sleep, we give them kind of a transportation recorded noise, and we just give it to them for a few days, and then we look at the impact on health. And what we see is we see changes in endothelial function in an adverse way. We see increases in blood pressure. We see decrease in restfulness, worsening of quality of life, and worsening of sleep quality. So all of these factors have been associated with the risk of heart disease, and we have proven that these are noise is causal in this context. The third thing I want to mention, so we talked about air pollution, we talked about noise pollution. The important piece here is changes in temperature. So climate, as you know, climate change is impacting us on daily basis. There is increasing number of hot days in the world. The average heat is increasing by about 1.1 Celsius above pre-industrial levels. So a lot of this is clearly now linked to human activity and industrial revolution and post-industrial revolution. This can lead to heat waves that are increasing. And although we think of climate change as a heat-related thing, but that can also by itself leads to hurricanes and heavy rainfalls, and it also leads to some drought patterns, right? So all of these kind of intertwined things that can help can worsen health in various ways. But when we think about temperature, both hot temperatures and cold temperatures have been linked to health conditions, primarily cardiovascular disease. And when you look at heart disease, the impact of heart disease, the impact on heart disease from non-optimal temperature, that's both cold and hot, we see approximately 1.2 million deaths from heart disease occur every year because of non-optimal temperatures. So what is non-optimal temperature? That is defined locally for each individual country or each individual region. People adapt to different temperatures. So I would argue for Qatar, for example, because Qatar has adapted, and the Middle East generally has adapted to high temperatures. Cold has a significantly more impact. And in areas where, for example, Russia and North America, where people have adapted to cold temperatures, heat will have more impact. It's kind of counterintuitive, but that's the reality of what we find in the data. And the important piece is because the population is aging, people are getting older, then we are seeing an increase in these deaths related to temperature. Um, One area that I wanted to touch upon is really plastics. Plastics are all around us. You probably have heard about microplastics. This is not a microplastic. These are kind of small pieces of plastic, but microplastics and nanoplastics are very, very tiny um, plastic molecules or structures that we are starting to find to have linkage with health outcomes. Um, so these microplastics are tiny, between 1 micron to 5 millimeter, and then the nanoplastics are even smaller than 1 micrometer. And there are different contaminations. So we see it in soil, we see it in ocean, even in some fish. We see it in air. Some of it is suspended in air. And we start to see that humans get exposed to them through multiple ways. So inhalation is one, ingestion is another, and then kind of this concept of things get embedded into our GI tract or in our lungs that can go and translocate and go from these areas of lung and GI tract into the rest of the organs and can have a significant health impact. So when we start to look into samples that are taken from people undergoing surgery for their neck, so there's carotid artery in the neck that people go for surgeries. This gets a lot of plaque because of cholesterol buildup, and we take these samples during surgery. So these are surgery to open up these arteries. Uh, and we take these samples and we look under the microscope. These are called electron microscopes, which are very, very powerful microscopes. We start to see that there are microparticles that are inside these microplastic particles that are inside the immune cells that are called macrophages. And these, interestingly, we see a lot of these in some plaques, and we see few in other people. So the risk is not homogeneous. In some people, we see a lot of it. In some people, we don't see a lot of it. And interestingly, when we look at people who have a lot of it in orange, they have a higher risk, approximately 4 times, 4 to 5 times risk of having a heart attack, stroke down the road, compared with people who don't have these particles. So there's an interesting finding here. This is still to be understood. This is very early signature for early sign of this health impact of micro and nanoplastics, but these are areas of active research that people are looking into and that are very worrisome at this point. We're starting to see these in carotid arteries, but not only we see them, but they have a long-term impact, approximately up to about 3, 4 years of doubling the risk or fivefold increase in the risk of heart attack and strokes. And what's even more concerning is we start to look at different organs and we start to see those. So everything that is lighting up here in kind of these orange color, these are all microplastics in the kidney. This is in the liver. We start to see it in the brain as well. And this is what it looks like under this very high resolution microscope. You can see these kind of small threads of particles. These are all microplastics and nanoplastics that will have, we need to study how they impact these different organs. So generally, what we think about this is what we call the life course of humans, from an embryo, kind of in womb, fetus, infant, child, and adult across the life years. And then as people get older, they start developing risk factors, diabetes, high blood pressure, things like that. And they start having events like heart attacks, strokes, and things like that. And we think about if you're exposed to a healthy environment, a healthy exposome, then you live longer. You can see this curve is a little longer, but you also live healthier. So over time, you get less risk of cardiovascular risk factors, but also less risk of cardiovascular events. And if you live in an adverse environment or bad environment, which could be high air pollution, things like that, then you develop disease earlier and you live shorter. And although environmental, when we talk about the environment generally, we think of the environment as being bad, right? It's bad, it's the bad thing, right? It's kind of air pollution, things like that. We also have to think about the beneficial part of the environment. So how do we address circadian or the changes in your rhythm or sleeping pattern? How do we support your immune system? What are some of the things in the environment that can also improve our stress resilience? So there are a lot of different things in the environment that can help us deal with these bad things on the environment and balances it. And one of the things is really walkability, living in a walkable environment, living in, kind of accessing nature, seeing nature more, seeing green space more has been shown to improve health outcomes. And there's a lot of studies that have shown that green spaces, specifically parks, and that are and nature access can improve oxygen production, can change, has a very positive environmental effects. It has a lot of positivity on social effects because you interact with others, which have a good health benefit, but also have good human effects. And this is a bunch of studies that are pulled into one analysis that showed for each increase in the unit of green space that you have in your neighborhood, you have 2% reduction in risk of having a heart attack, stroke, dying from heart disease. I'm going to skip these for a second, but I think the kind of just whenever I give talks like this, people ask me, okay, what can I do? And there's actually interesting things that can be done that have been evidence-based studies that have looked into the impact, for example, of how can I reduce my exposure to air pollution. There is these personal or portable air cleaners that are available in the market. You can put them in your bedroom and then you can run them, or sometimes you can put them as filters in your air conditioning systems. And these have been shown to improve the quality of the air, but also improve health outcomes. In some specific days where air pollution is so high, using N95 and 99 respirators can be helpful. And if you go to South Asia or even East Asia, this is a common practice that people monitor their environment, and if air pollution is so high, they start wearing some of these masks. And also, whenever you're driving, closing your windows has been shown to reduce air pollution. This is an example of multiple studies that have shown that just putting in a portable air cleaner like this in your bedroom can reduce the blood pressure by 2 units, 2.5 units on average, and it can have a significant impact on kind of blood pressure control over time in healthy or unhealthy individuals. And there are other things that we can do. So in addition to air filtration, avoidance of polluted areas obviously is good, but there's data to suggest that exercise can be helpful to counteract some of these effects. Dietary supplements are helpful. Staying indoor during air pollution days or high air pollution days can be helpful. And I mentioned personal face masks and air pollutions. So I'm going to skip this for the sake of time, just to keep time for questions. But I wanted to kind of bring this up to speed here to you for just a parallel between our planet health and our human health. So this is our human, what we call life course, similar to what I showed you earlier. This is childhood, early adulthood, middle age, advanced age, and elderly. And then we have this cardiovascular health decline continuum. So as you get older, you have a higher risk of having heart disease, having heart failure, and other problems with your heart. And this is what we aim to have at very old age. You live healthy and you have less risk of having cardiovascular health. And this is what the average human life course is right now. And then we have a early cardiovascular aging. So people who age very fast, they have a higher risk of cardiovascular disease. But in the same kind of arena, the same demonstration, you can actually also look at planet. So this is our pre-industrial, industrial, current, and future. What we want is and this is planetary health decline. So think about the planet is also has a health and it's declining in general. So what we want is we want to keep it the way it is, right? We want to have an ideal planetary life course. But unfortunately, the current average perspectives are talking about kind of worsening of our planet health over time. And if we continue to do more and more harm to our planet, whether by increasing our air pollution or plastic use and everything else that is bad that we're doing to the planet, then will lead to early planetary aging, which will have a humongous impact on our human health. So I want to just conclude by saying that environment has a huge impact on our health. There is emerging evidence to suggest that urban environment and maybe some smart city design and alteration of your natural environment can improve health outcomes. We also have to recognize that our health, environment, and planet and animal health are all connected. This concept of One Health should be front and center for all of us, and we have to think about policy interventions that can help us in designing cities and designing urban areas that are promoting healthier neighborhoods. So I'm going to stop here for the sake of time, and I'm happy to answer questions.
Thank you very much, Dr. Sadeer, for your time. I thought that was a very thought-provoking talk. And I really liked how you connected the environment and the health of animals to the health of humans, because our quality of life is really dependent on all of the above. I want to take this opportunity to remind everyone who's here that if you have any questions, please put them in the chat, and we'd be happy to pose these questions to Dr. Sadeer. In the meantime, I do want to start off with something you sort of touched on, but perhaps you would like to elaborate, especially when it comes to these kinds of environmental exposures. Are there specific times during life or specific age groups that we need to be particularly careful about when it comes to these kinds of exposures?
Yeah, so very good question. And it depends on the type of exposure, but generally, we think of people who are susceptible to harmful conditions. And these harmful conditions could be anything from temperature to air pollution to noise. Individuals generally at the extremes of age, right? So elderly individuals more than 80 years old or younger individuals less than 1 or 2 years old. These are what we consider to be, and this is a concept across medicine, right? I mean, anything that from an infections to environmental exposures to everything in medicine, we think about the extremes of age because at these times immune system is not very well developed in young people or has been exhausted in older individuals. And the availability of the immune system to counteract some of these impacts has been limited. Generally, we think of people who have low socioeconomic status or low socioeconomic position as also being more vulnerable to these impacts. There is some data to suggest that there is also some sex-related differences, although this is not very clear. In some aspects, women have higher risk. In some aspects, men have higher risks, and it all depends on the environmental exposure itself. But we think of it as a life course, kind of across the years, and things have been building over the years. So similar to how we treat your cholesterol, which is basically building over the years, air pollution, we should also establish a total average for the years to examine the impacts total in totality.
Right. Thank you for that. We have a question from one of our attendees, specifically asking about causality when it comes to microplastics. So, how is it that scientists and healthcare professionals can determine causality in terms of the health outcomes as opposed to, oh, this is just a correlation? Can you touch a little bit about that, please?
Yeah. So that's always the concept with the environmental science is really it's difficult to establish causality. So the way that we do it is generally by taking the totality of science, right? So in some aspects, for example, in humans, we're studying these tissues that are acquired either at death, in autopsy studies, or prior to death, using biopsy samples or samples that are taken through surgery and things like that. And then link them with the amount of plastic, for example, link it with the health outcome in question, whether it's dementia or that happens after the fact, or heart attacks or strokes. So that's one way of looking at it, and still is observational studies, right? So there are limitations, confounding factors, and so on and so forth. So the causality may not be inferred only from this. So what we also typically do is we do animal studies. So we expose animals in a very controlled experiments, rodents like mice generally, and then they get exposed to high levels of plastics versus low levels of plastics. And then over their time, which is generally a few weeks, we can actually sacrifice these animals and look under the microscope. We can also examine their health outcomes in general over that time period, right? And there's everything in between where we take cells outside and expose them to plastics and look at the response of these cells and so on and so forth. So it's not one thing that would lead to this. And air pollution is slightly easier because we know how we're exposed to them and we can actually run randomized trials. So these, what I showed you today, the causality was inferred primarily from randomized trials that have shown that we have two types of randomized trials, either expose you versus not expose you, which we used to do a lot in the past decade, but it's no longer done as much because now we realize it's a harmful thing. And then now we take away air pollution from you. So we look at people who are living in highly polluted areas. Qatar, we're running a trial. Dr. Sharbel Abi Khalil is running a trial in Qatar that looks at air pollutants and kind of randomized trial, sham controlled randomized trial. So very high quality trial to remove air pollutants using portable air cleaners and seeing the impact on blood pressure. So it's a combination of things. I wouldn't say that it's one thing to establish causality.
All right. And on a related note, do you see things like technology, AI, wearables playing a role in terms of trying to determine risk, causality, health outcomes, and so on?
Yeah, no, very good question. So, for microplastics, it's still very limited. I don't think that's going to happen. But for for air pollutants, now we have wearable devices that can measure air pollution directly. And then at the same time, it can actually measure, we have other wearables that look at your heart rate changes and your blood pressure changes and things like that, and sleep patterns. So by looking at the lag time, the time between the exposure and the time of the event that is happening, for example, continuously over day, over day, over day, to look at the changes in sleep patterns, look at the changes in your heart rate. And then we can establish strong relationships. And it has to, again, in by itself does not establish causality, but it can establish at least a hypothesis generating. And in the context of everything else that we studied, then yes, it can be added in the whole story.
Mhm. All right, so I see another question here, basically asking about when we're trying to mitigate our exposures. Regarding exercise, is there something that is preferred in terms of aerobic or cardiovascular activity versus resistance training, or is it a mix of everything? What is your recommendation?
Yeah, so generally what's been studied is aerobic exercises. We still do recommend what the American Heart Association recommends, which is about 150 minutes of moderate exercise. So I usually describe this as exercise that allows you to to talk, but you cannot have a full conversation. It's uncomfortable to have a full conversation, but you can say a few words at a time. And this is basically 150 minutes a week. Now, the caveat to this is that you have to be aware of your environment or the pollution levels during that time, because exercise increases the amount of air that you're breathing. And at some point, if you're increasing the amount of air that you're breathing and the air is so polluted, you can actually worsen your health outcome. So you have to be aware of your environment. And at least in the United States, we have something called AQI, or Air Quality Index. And I believe Qatar may have something similar, where it tells you that there is a significant, this is not a good quality air for exercise. So avoid exercise during this time. Avoid exercise during this time. And this needs to be adapted for the local context, because if you just apply the US levels to Qatar, you'll be in unhealthy environment all the time. So I think there are some limitations in some of these aspects that need to be studied for the local context.
Yes, I believe there are several apps that do track the air quality here. So, and also I believe the Ministry of Environment here has they measure air quality and they publish the results online. So there are ways for us to keep track of the air quality. So that is an excellent suggestion. Um, Another question that I see is, so you talked a little bit about the exposure over the life course,
Yeah,
but you also talked about all of these different environmental exposures, so air pollution, noise exposure,
yeah.
climate change as separate entities. But is there any evidence in terms of the combination or cumulative effect across all of these exposures on health
Yeah.
outcomes?
Yeah, I mean, I think for simplification purposes, I did want to separate them because conceptually they are different, but in reality, they actually all happen at the same time. And there's a lot of evidence to suggest that coexistence of pollutants can be more impactful or harmful compared with single exposure. There's also evidence to suggest that there is an additive effect of different pollutants or to noise. For example, if you're exposed to high noise plus high temperature plus high pollution, then the impact is amplified. Not only additive, but sometimes it's even more amplified. So kind of multiplicative. So there is some evidence. I don't know if we know this for sure yet in high quality studies, because it's very difficult to do this in a randomized fashion to change all of these in experimental designs. But I think the science will evolve to actually be able to capture some of these individual exposures at the same time.
All right. I'm not seeing any other questions in the chat. So, Dr. Sadeer, if there may be one or two key points you want our audience to take away from the session.
Yeah, I think if there's one thing, just realize that environment shapes our health in ways that we underestimate quite a bit, right? I mean, something that, we need to kind of think about the environment, be aware of the environment. So that's number one, and I hope that I've convinced you that way. But the second thing is really we also impact the environment in ways that we underestimate. And every one of us has their own role in harming the environment. And this is something that is unfortunately, although we have some preventative therapies for human health or human disease, we don't have much in terms of preventative or curative kind of ways to reverse the planetary health issues. So think about the things that you're doing on daily basis, right? If you're not sitting in a room, you don't need power, turn it off, right? If you don't need to, if you can search for something instead of asking ChatGPT, the use of AI these days can increase carbon footprint significantly. If you don't need to drive, for example, think about how you become environmentally conscious. The reduction in microplastics, which can both harm the planet and human health potentially. All of these things you have to think about, and I would urge everybody to think about the harm that we're causing to the environment as part of our daily life.
All right. Thank you very much, Dr. Sadeer. I really enjoyed this session, and I hope our participants also did. Thank you to the participants for taking time out of their busy schedules to join us. And I hope you will all join us in our next session. Have a
Thank you
good day,
all for
everyone.
attending. Appreciate it. Thank you so much.